Are you struggling to understand what DevOps is? Has every video that you've watched left you more confused than the last? Well, you're in luck. In this video, I'm going to explain exactly what DevOps is and why it's really important to every single company, including yours. My name is Jarrett Coggin, and I'm a DevOps engineer with over a decade of experience. I've worked at all sorts of companies of all different sizes, such as Yahoo, Tesla, and Twitch. Everything that we're about to discuss is for like a web company. It's a little bit different when you're deploying desktop software or a mobile application. But for the purposes of this discussion, we're going to be talking about how software is released for a website. In a typical tech company or any company that's developing software, the software development lifecycle goes something like this. Key stakeholders such as business analysts, developers, quality assurance, other people who are interested in the software come up with features that need to be developed. Software engineers work on developing a new version of the software. They're fixing bugs. They're doing a lot of local development. They might be integrating with each other, getting builds ready to be tested by the quality assurance and business analysts. The software engineers are doing multiple rounds of deployment to different types of environments. These could be development environments for the software engineers. They could be quality assurance environments that the quality assurance team validates on. They could be staging environments that the business analysts will use to validate if the software is ready to go out to production or not, and if it's ready, if it actually has the features that they need to deliver. Once the software has been tested, verified, gone over with a fine-tooth comb, they get to the point where they're ready for a release. A deployment artifact is generated and ready for deployment to production. Whenever we're talking about a deployment artifact, we might be talking about multiple microservices. We might be talking about one big, huge jar file that's run as part of a website. It's ultimately, we're using deployment artifact as everything that's needed for that new version of the application to go out to end users. The software engineers will send over a deployment artifact with information on how to release that software out to the production environment and out to end users. At some point in time, the operations team will typically schedule a release. The operations team will use the notes provided by the developers, and they will go through the process of taking the new version of the software, the deployment artifact, and rolling it out onto the production environment. Now, in the case of a small website, this software might be rolled out to just 2 or 3 servers. But in the case of a massive company, think Google, Apple, Facebook, Instagram, Yahoo, that software might be deployed to hundreds or even thousands of servers. So the operations team really needs to have accurate directions on how to release that software out to end users. When software is released to production, usually the development team, the quality assurance team, the business analysts are on call for that release in the case of any issues arising. Sometimes the quality assurance team is on hand to say like, oh, this bug isn't a big deal. We can fix it in the next release. Sometimes the business analysts are saying like, hey, this isn't working exactly as we expected. And so they call off the release, and maybe even a rollback needs to happen in order to get the software into a good state. Regardless of whether or not the release is successful or not, the operations team is still on hand. They are monitoring the servers, they're monitoring the application that's been released, the software that's been released, to make sure that there are no issues as a result of the actual release. If the release is successful, the development team gets to move on to the next big thing. If the release isn't successful, the development team has to go back and perform bug fixes and resolve any issues that happened as a result of the release. This might result in another release happening in short order. It might be hours or days, maybe even a week, depending on how slow the release cycle is for that company or that team. If a release is successful, then hopefully a little bit of goodwill is gained between the development and operations teams. The operations teams might trust the development team a little bit more, and so they might take releases in. And they're like, oh, these are less risky than we thought. In the case of a failed release, usually the relationship between a development and operations teams gets a little more soured. Operations will say, like, we need to see a signed off set of use cases in order for us to take a new release on and actually roll it out. We need to do our releases during lowest usage times. That might be late at night or very early in the morning. It might be done on the weekend. Over time, if those releases continue to be an issue, more and more hurdles, more and more, for lack of better words, red tape gets put in place, typically by the operation team or by business analysts or even the QA team, so that they can hopefully make a release more successful in the future. What this ends up doing is it slows down releases to the point where it may take a company days, weeks, months to get ready for a release, and then it becomes a much bigger, more orchestrated affair because more and more things are piled in to future releases. Regardless of the status of the release, the operations teams monitor the environment. They're monitoring and making sure that the software is working as expected for the end users. Whatever process a company comes up with for their software development lifecycle is usually a byproduct of their growth over time. The company may not have taken concerted efforts to improve their build, release, validation processes to make sure that they're shipping high quality software out to end users quickly. The longer a company has gone without working on these processes, the slower and slower they're able to deliver their software into the marketplace. Something that might have previously taken hours or maybe even a few days to get out the door, to go from idea to actually in the hands of customers, might turn into weeks, months, or even years in extreme cases. There also might be cases where a company has really long release cycles, software development life cycles, due to the type of industry they're in or the type of software that they're working on. You might think of software for medical devices, like an MRI machine or a defibrillator even, or an organization like NASA, and they're writing software for space shuttles and rockets. There is no option for failure. A critical failure, then it results in hundreds of millions or billions of dollars going up in an explosion and people being killed as a result of one small mistake. Now that we've talked about how the software development lifecycle for a company can decay into like this unmanageable state, let's talk about some of the pain points that development and operations teams face. Development teams want to be able to move on to the next fun thing. They want to get away from just like trying to get this software release out the door, and they want to work on the fun parts. They want to build new features. They want to fix long-standing bugs. They want to write code to dramatically improve the performance of the software. Operations teams want to keep the production environment up and running as much as possible. They don't want to have downtime for users, and if anybody runs into any downtime, usually the operations team is the first people that gets notified of that, if they don't already have logging and monitoring in place to notify them proactively. Anytime there are changes to the software, this change introduces risk. That's risk of bringing the environment down. That's risk of new bugs. That's risk of decreased performance where new servers need to be bought and managed. If the operations team feels like the software that they're getting from the development team isn't high quality and that it hasn't been rigorously validated, the operations team may push back on the development and quality assurance team to do more testing, to do more validation, to schedule that software to be released during maintenance windows, or various other steps to try to reduce the risk of the environment breaking and the application being down for end users. These maintenance windows sometimes are at inconvenience times. They might be late at night, they might be done on the weekend, things along those lines. At the same time, if the development team feels like they're getting unnecessary pushback from the operations team, they might go so far as to try to set up their own environments and switch the ownership of the actual application environment to themselves, where they manage it away from the operations team. The development team might do this to try to speed up their release cycle and ultimately sidestep some of the internal processes that the company's put in place to help ensure the software is reliable and stable for end users. In extreme cases, this can result in all sorts of issues like security breaches, failed audits, and even fines for the company. All right, now that we've given you some background on the software development lifecycle, how software gets out the door, and how the development and operations teams might be at odds with each other, what is DevOps? How does DevOps solve this? What does DevOps even mean? What ultimately needs to happen is the two teams need to come together and figure out a way of working together. When the two teams come together and get on the same page, and when they start to figure out ways to work more effectively, they often realize that they're on the same page. They want the same things. The development team wants to have an application that runs well for end users and that stays up all the time. The operations team wants to enable the new features to go out the door quickly so that it can get in the hands of users in a fast pace. This combining of forces results in a culture shift that we call DevOps. As you may have figured out, is development and operations combined. DevOps is less of work that needs to be done, but it's more of a culture change in how an organization works to get software out the door quickly, effectively, and with high quality. DevOps is about combining the skills of both teams. Developers are great at writing software to automate things, while operations engineers are great at rolling out software to allow servers or on a large scale and to make sure the environment's up and running well for end users with little downtime. The operations team is also great at monitoring and keeping an eye on all sorts of different issues that may be arising that this development team may not be aware of in the first place. By leveraging key capabilities of both teams can work together to make application releases easier, faster, and less error prone. The two teams can work together to create reliable, repeatable, automated processes to quickly release software out the door to end users while providing fast feedback to both teams. This is done by automating all of the manual work that's needed to build, test, deploy, and validate software, while at the same time implementing fast feedback loops for both teams. By automating all this manual work, development teams don't need to burden the operations team with tedious, repetitive manual work. And operations teams know that the software is going to be released out to the production environment in a safe, secure, reliable, repeatable way that they approve of. So, what does this look like in practice? If you've looked around on the internet, you may have come across the unofficial DevOps logo. It looks like an infinity symbol with the various phases of the software development lifecycle that we discussed earlier around the various points of the symbol. Each of these phases of the software development lifecycle has steps that can be automated to improve the process of getting new software out the door to end users faster. In the early phases, development teams know what's needed to build, deploy, test, and validate the application so the development team can help automate those steps. In the middle stages, development and operations teams can work together to identify any issues that might arise during deployment by deploying out to a pre-production environment. If there are any issues arise here, both teams know about those issues, can work together to remediate them before they try to deploy out to production. In the later phases, the operations team knows how to release the software out to users and monitor it for any issues so they can help with the automation around that. The development and operations team, throughout this process, can find ways to automate these processes, regardless of the environment. They might decide to use the same deployment process, not only for the production environment, but for the non-production environments as well. The software engineers might introduce new forms of logging and metrics gathering in the application that can be fed into the operations team's tools so that they can get the information they need and identify any issues before they come up. The operations team can also take that information and feed it back into the development team and identify all sorts of issues. Maybe the development team has introduced some more logging and now it's filling up disk space on servers much more quickly. So instead of an outage occurring, the operations team is monitoring disk space and they can implement automated processes, maybe automatically delete logs after 30 days that are no longer needed, or offload those logs into dedicated tools like Splunk or Datadog. The operations team can work with the development team to implement an automated release process. They might also implement monitoring and logging and metrics gathering to identify any potential issues in the future and get ahead of things that just might occur naturally as a result of increased usage of the application. The operations team might look for increased resource usage, such as CPU utilization spikes, memory leaks in the application, disk drives that are filling up due to logging a lot of error messages. They could feed this information back to the development team, who can then go work on the application, fix these issues in the software to hopefully make the application more stable for end users. The operations team can work with the development team to figure out ways to surface this information to them in an easy to consume way, allowing the development team to get ahead of issues before they even crop up for the operations team. Ultimately, by implementing all of this automation, the development and operations teams can work together to release more secure, higher quality software faster in a more efficient and more effective way, so that the company and the teams can respond to changes in the market faster. Maybe there's a new competitor in the market. Think about YouTube releasing shorts as a competitor to TikTok and Instagram Reels. If they didn't have automated processes, if they didn't have the ability to quickly respond to the market, YouTube Shorts may never have happened. And TikTok and Instagram Reels may be eating their lunch. Another benefit of all of this automation work is that there can be more releases done more frequently. And the way this actually aids the company is that less changes to the application are delivered as a part of each release. So releases are smaller and smaller over time. And it's easier to find any issues. It's easier to roll back because you're not doing such a massive release where you're combining a whole bunch of changes into one big release. Smaller changes are easier to recover from. It's easier to find any issues that arise as a result of a smaller release that has fewer changes in it. Let's say you find a bug in a release that has 10 changes. That's a whole lot easier to find than in a release that has 200 or 300 code changes in it. It's easier to figure out who contributed changes as part of that, and it's easier to get a fix out the door faster because it's typically been less time since that person's been working on something else. So they have less context switching. As a result of smaller releases, companies can be more agile in the market. They can respond to changes. They can respond to issues that crop up. Whenever the Log4j security issue popped up, companies that had automated release processes, that had effective CI/CD pipelines, continuous integration, continuous deployment pipelines, if you aren't familiar with that term. Companies that had these automated processes in place that allowed them to release software quickly to get new features and new versions of their software out the door fast, were able to respond to that and were able to close that security issue more quickly. Now, let's get more concrete and talk about specific types of works that a company that is adopting a DevOps culture might need to do as a result of those changes. At the start of this video, I mentioned that I'm a DevOps engineer with over a decade of experience. And here's some of the work that I often get brought in to do. Implementing CI/CD pipelines. Automating all the manual work needed to go from commit to production in a completely automated way with no manual intervention is something that's actually possible. Now, some of you might be thinking to yourselves, like, I can never imagine my company ever being able to do it. But I can assure you that being able to, a software engineer to commit their code to source control and no manual work whatsoever is done by a single person on any of the teams, the development team, the quality assurance team, the business analysts, the operations, anybody, to go from the developer committing their code, it being completely validated, security, performance, the whole 9 yards, to it being rolled out to end users on a production environment is completely possible. Some of the work I also get brought in to do is I work on improving logging, monitoring, and observability. This is work that's needed by the development, quality assurance, business analysts, and operations teams to improve the overall quality and reliability of the software and applications that the company provides. This is work that's needed for the development team to build high quality, reliable software that's easy to understand what's going on with it as it's running in production or any other environment for that matter. It doesn't just have to be tied to production. It's also work to help the operations team get ahead of any potential issues. Maybe disk drives are filling up, maybe the CPU usage is starting to spike, maybe there's a memory leak in the application. If the operations team is able to see these type of issues occurring, they can go to the development team and say like, hey, we're seeing this, we need you to go in and fix this. It seems like it might be happening with this portion of the application, or we're seeing these types of log messages in our observability tool. Another thing that I can help the operations team do is by having the logging, monitoring, and observability is that it can actually help them get ahead of any potential events that are coming up. Maybe the company is releasing a new product. This happened whenever I was working at Tesla, and we were coming out with the Model 3, and we were taking pre-orders for it. And in the course of a single day, we received over 100,000 pre-orders. And at this point in time, they weren't even really selling 100,000 cars a year. And we received 100,000 pre-orders in less than 24 hours. So whenever I'm talking about like big events, like this could be one of the big events. Maybe there is a sale or promotion that's gonna be going on. Or maybe it's just a natural thing that happens every year, like the holiday season where people wanna buy gifts for the various holidays. Another thing that a DevOps engineer can help with is addressing different types of changes that happen as part of a release. Now, we talked a little bit about like implementing CI/CD pipelines and having a fully automated process to go from commit to production. That doesn't just happen for code changes. That type of thing can also happen for configuration changes. It can happen for operating system updates. It can happen for database schema changes. So a 3-tier application has a front-end web server, it might have a back-end API server, and it might have database servers. But there's more to it than just that. In a highly available application, there's probably networking components, there's load balancers, there's underlying operating systems and frameworks that might need to be installed on specific servers. And all of these things add up to consist of the actual application. DevOps engineers would work with both development teams and operations teams to help figure out the exact order of changes that might need to happen as part of a release and ultimately build in that type of change into the CI/CD pipeline. So you might provision another server, and so that might be an automated process where you change a single number in a Terraform file to provision another server in like an auto-scaling group, and then the load balancers have to account for that new server, and that automatically gets updated as well. When that server boots, software has to be installed on it, and so that might be automated as well. And so all of these things can happen as part of a given release. And so DevOps engineers come in and they look at all these things, they help figure out kind of like an order of operations and help the team be able to automate these types of processes. Another type of work that I've been tasked with is actually looking at processes and seeing what needs to be done to make them more scalable. And what I mean by this is, let's take, for example, a automated script to do an application deployment. This might work well whenever you have 1, 2, maybe 3 servers. With the way the script is built, it might SSH in servers and do the actual deployments. But once you start going from just a handful of servers up to tens, hundreds, or even thousands of servers, the types of processes that are needed and the types of tools that are needed are completely different. And so a DevOps engineer can look at this and evaluate different tools kind of separately from the team and come in with a proposal or a solution to help address scalability issues. Now, it isn't just for like software and automation that has been written, but it can also apply to teams and the processes teams go through for actually developing software and getting software out the door. I might go into a company or an organization and look and say like, oh, you're planning on hiring, you're planning on doubling team size. Maybe you're going from or quadrupling team size even. You might go from 50 engineers to 200 engineers over the course of 12 or 18 months. What things need to happen to help address those types of things? How does the CI/CD infrastructure need to change? What needs to change from like a server setup or an infrastructure setup? Do we need to look at the way that builds are currently done and figure out how to do this in a way that applies not just to one team, but to 5 teams or 10 teams? And how do we do it in a way that it's easy to pick up for a lot of different software engineers or operations engineers that have a variety of expertises, experience levels, and skill sets? And so that's something that a DevOps engineer might be brought in to do. Eventually, a company might decide they want their development and operations teams to focus more on their respective traditional skill sets. So they want them to be less of jack of all trades. The company is probably growing, and they might go from 5 engineers that they don't really have maybe an operations team, or they don't have DevOps engineers. And so they've gone from 5 engineers to 10 engineers to 20 engineers, and everybody's just been kind of handling the work, but it's not been done well. And so the company starts hiring specialists. They might start hiring their first database administrators. They might start hiring their first operations engineers. And usually what happens, in the case of DevOps engineers, I think companies start looking at DevOps engineers once they hit about the 20 to 25 engineer mark. They start thinking about it. And I think 30 to 50 engineers, and I'm not just talking software engineers, but I'm talking software engineers, quality assurance, operations, or systems administrators. That's usually when they start looking at hiring their first DevOps engineer as a more specialized role that is a capability on their team. And so that's usually kind of the benchmark that I've seen companies say, like, yes, now we need somebody who can kind of bridge that gap between development, between operations, and start bringing in this type of culture that we need that augments both teams and helps both teams do their job more effectively. A lot of times, whenever a company brings in a DevOps engineer, it's just having a new influence and a fresh pair of eyes looking at their processes, looking at the procedures they've been following to get their software out the door, and saying like, oh, what can we do? Like, what is the internal work separate from the application, separate from the development teams or the operations teams or the business analysts or the quality assurance? What is the work that actually needs to be done to kind of glue all these teams together and help them actually work a lot more effectively and efficiently? And so that's where I think that a company getting that fresh set of eyes and looking at, hey, they've been operating this way and they kind of seem to be in a rut, and what do they need to do to shake things up and get them out of this rut, but with a concrete focus of looking at processes, automation that needs to be built, software that needs to be brought in. Kind of what are the gaps in the holes that the team might be experiencing, or the organization has, that it slows them down from delivering software quickly. A DevOps engineer might come in and say, okay, you don't have a very good build system, or your build system is non-existent. You don't have, like, whenever we go from environment to environment to environment, those environments may not be configured the same way. The servers are running different operating system versions, or they're running different versions of the framework. They're configured in different ways. What needs to be standardized at that level? And then they might say like, oh, this team is deploying their applications one way, and this team's deploying it another way, and this team's deploying it a third way. And like an example of this might be that this team is deploying their application onto virtual machines, and this team is deploying their application in Docker containers or container images, and this team is deploying it on something like AWS Lambda. While all of these ways can work and they're all good at different things, like, how can we standardize this? And maybe we bring in something like Kubernetes and have all of the teams deploy their software the same way and leverage it at that level. That way we can simplify all the deployment process for all of these teams. Hey, if we're just deploying Docker containers on Kubernetes, then we can start breaking these applications down a bit more and make it so that they are easier to deploy at the same time. The individual pieces are easier to deploy on their own, and we can have faster deployments by deploying smaller pieces at a time. Like this video if you found the content helpful. Subscribe to this channel if you would like to hear more of what I have to say on DevOps and AWS. Leave me a comment if there's something specific you want me to discuss with DevOps or AWS. Follow me on LinkedIn at linkedin.com/in/JarrettCoggin and stick around for another video about DevOps and AWS.